In 1.16, we're going to introduce the intermediate value theorem, and it's going to make sense. This is going to make sense based on the information they give you. Okay, so there's some criteria that must be met to use the intermediate value theorem. The first criteria is that f must be continuous. Let's say from A to B. Okay, and then I'll go ahead and sketch a graph down here. Let's make this A. Let's make this B. And then there's some graph F that's continuous from there to there. I don't know what it is. And I don't know what it looks like. Oh, A to B. Let's cut this. Now let me make it a little taller actually. Let's say it goes up to here. Okay, there's my graph. F is continuous from A to B. Okay, that means that at this point, this y value, this is f of A. At this y value, this is f of B. Okay, now we're going to select a y value that's between f of A and f of B. So I'll just make up a y value. Let's call it K. Okay, now if K is between f of A and f of B, okay, then the conclusion is there exists some x in AB such that f of x is equal to K. Okay, I'm going to use an abbreviation. Okay, for there exists, if you use a backwards capital E, that means there exists. Okay, there exists an x value in between A and B such that f of x is equal to K by the intermediate value theorem. Okay, let's look at the graph real quick. Okay, so I know that this graph is continuous from A to B. So this graph goes from f of A to f of B in the y direction. Since K is between f of A and f of B, and since the graph is continuous, it makes sense that there must be some x value such that f of x equals K from here to here. Just to get from here to here, if there's some point in the middle, there has to be a point that gets me that point in the middle. That's what the intermediate value theorem is saying. Okay, so what might they ask you involving the intermediate value theorem? Okay, for the first one, they're going to give you a table of values. Okay, and they're telling you this is representing a continuous function f. Okay, now the first question, from 0 to 9, this is 0, this is to 9. What is the minimum number of zeros? I don't know exactly what happens, but I should be able to tell if there's going to be a 0. And remember, a 0 means when does y equal 0? Okay, so let's look at what they give me. Okay, starting at 0, the y value is 1. And then from 1, it goes to -5. In order for it to go from 1 to -5, it has to pass through 0. So there's got to be at least 1 0 there. Now, if I go from -5 to 3, I've got to hit the 0 again. There's no way for me to get from y equals -5 to y equals 3 without passing through 0. Now, from 3 to 7, no, there's no reason I have to pass through 0. I might, but I don't have to. From 7 to -1, yes, I would have to pass through a 0. So in this case, there's at least the minimum number of zeros. There has to be 3 according to this table. There could be more, but there has to be at least 3. Okay, now let's look at the next question. On the interval from 4 to 9, so 4 to 9 is just looking at this part of the graph, or this part of the table. What's the fewest possible times f of x is equal to 1? So I'm going to look at the y values again. Okay, 4 to 9. So first I go from 3 to 7. Do I have to pass through 1? No, I don't. I have to pass through 4, 5, 6, 6.2, and all those other numbers. Now if I go from 7 to -1, do I have to pass through +1? I do. There's no way I can get from y equals 7 to y equals -1 without passing through y equals 1. So there's 1 as the fewest possible time. Okay, let's look at the next question. Okay, from 0 to 4, where 0 to 4 is from here to here. Must there be a value of x such that f of x equals 2? Let's see. Okay, so from 1 to negative 5, do I have to pass through y equals 2? No, I might, but there's no reason I have to pass through it. Okay, let's see. From negative 5 to 3, to go from negative 5 to 3, I'm going to have to pass through y equals 2. So must there be a value such that f of x equals 2 on that interval? Yes. Okay, let me justify my answer though. So what are the criteria for an intermediate value theorem? The first thing is that it must be continuous. Okay, so f of x is continuous from 3 to 4 because it said it was a continuous function. Because 2 is between the negative 5 and the 3, which is the value at x equals 3 and the x equals 4. So 2 is between f of 3 and f of 4. Okay, then I can conclude. What am I asking? There must be a value? Okay, there must be a value x such that f of x equals 2 by the intermediate value theorem. Okay, let's go ahead and look at number 4. It says on 4 to 8, could there be a value of x such that f of x equals negative 2? Okay, from 4 to 8. Okay, the y values go from 3 to 7. So does not have to be a value such that f of x equals negative 2. But could there be? There could be, because the graph could make a dip down below. So since it's asking, could there be a value such that f of x equals 2? Yes, f of x could equal to negative 2. But it is not guaranteed by the intermediate value theorem because it doesn't meet the criteria. So it might happen, but I don't know for sure it's going to work. I actually don't know that much about it. Okay, let's look at one more example where we could use the intermediate value theorem so you can see how you would use it in this case. So it says, is there a solution to x to the 5th minus 2x to the 3rd minus 2 equals 0 on x is an element of 0 to 2. So x is between 0 to 2, including 0 to 2. Okay, I'm trying to see if it equals to 0. Okay, in order to use the intermediate value theorem, I first need to know that f is continuous. So is this continuous? Sure, it's a polynomial function. So the first thing is, if I consider the function x to the 5th minus 2x to the 3rd minus 2, it is continuous on 0 to 2. Because it's a polynomial theorem, there's no polynomial, there's no discontinuities. Okay, now let's check f of 0 and f of 2. So at f of 0, 0 minus 0 is negative 2. And f of 2 is, what is that? 2 to the 5th is 32 minus 2 times 8 minus 2. What is that? 14. So f of 2 is 14. Okay, so could this equal to 0 between 0 and 2? If I go from f of 0 to f of 2, I'm going from negative 2 to 14. So because it's continuous, I will need to pass through 0 in order to get there. So by the intermediate value, I can conclude there is an x. Hold on, I spelled there wrong. Between 0 and 2, such that f of x equals 0 by the intermediate value theorem, because I met the condition that it was continuous and that the y value I was seeking was between the two endpoints.